Okay, so here is a DRV. Here's our user interface. There's a little orange tab that kind of fits through, and that's actually a part of the this orange tray. This feed neck is metal, and it's actually screwed into, it's secured into here with 3 screws. Pretty neat. So this collar is also metal. The collar and the feed neck itself are one piece. And then I haven't taken it out actually. That feels like plastic, but they must have some metal inserts or something in there. So you can tell that there's a lot of like sculpting and geometry on the inside of the shell to get this to sit pretty tight to the tray. The top shell, you'll notice, very different, very much kind of featureless. 2 screws hold this guy on in front. There's 2 screws there. I've only got one hand, so I won't take it off right now. And then here is the tray. So there's 2 little tabs right here. So you can kind of see that there's a little black tab there. And we've got to kind of rock this forward to get the black bottom tray, which is part of the raceway, to get past that little black tab, which now you can see. There's no tools to this. There's actually just magnets holding this thing together. And then here you can see there's a slot, and this tab on the battery holder engages the slot. Okay, so that engages the slot, and then that locks together. Okay, so here's your raceway. Here's what they call the clutch. We'll be digging into that so you can see kind of how that works. The raceway's got a couple of unique features here, where if you are contra rotating the feed, you're rotating backwards, the balls are going to ride up this little ramp, and then the raceway actually pushes them towards the center of the paddle, which you can see has got kind of a low profile little ramp of its own. So as the balls kind of push this direction towards the center, they ride up the top of the paddle, and so they're not crushed against this here. So this the raceway goes into a tunnel, so you don't crush it on a tunnel, you misdirect it towards the center. This is, there you go, so that's TPU or something. You can see here are the magnets, 4 magnets, which go to 4 magnet locations on our board. Our board does have 4 CIs. So here's 2 eyes here, and then diagonally across 2 more eyes, and those align to the 2 holes here and 2 holes there. Okay, so that's how this thing is. That's part of the sensing package that this thing has got. I can tell if there's a ball in the stack. I guess that would be the second ball above the breech. All right. Now this guy, I guess in order to get it, we probably really want to get in here so that you can see kind of what I'm talking about with this carrier bearing and everything else. So I'm going to take this apart. Okay, this is a weird thing. This is M2.5, and it's reverse threaded, so it's clockwise to loosen. Very strange alien technology here. Okay, so we've got a bearing here and a bearing on the top. This is our sun gear. You can see our planets in there. So this larger outer gear is actually the planet carrier. We'll move the planet carrier. You can see our planet gears. And you can see here's our ring gear. Now it's got 2 sets of gears. The lower set interacts with a gearbox down there, so I guess we've got a couple more screws to take off here. Okay. Gingerly. There we go. So that brass is just heat, what do you call it? Heat set insert in there. There is a little bit of grease. This gear is metal. This gear is metal probably because of the worm gear can create a lot of torque on that. So there you go. I haven't counted the gear ratio. You might be able to pull a part number off of that. Not that it really matters. It's just a little 2-watt motor, I'm sure. What else does this bad boy got? Oh, very strong magnets. Magnets hold on the magnets are also holding on the drive cone. Yeah, we probably should talk about, so this, I believe, this is the Hall effect sensor, B1. That's the Hall effect. You can see that that sits right on top of that magnet, right on top of this magnet, which you can see turns. And we'll dig into that in just a minute here. So I'm just putting this back together. Okay, so you've got a couple of gears that drives the ring, which drives the planets. Now, this clutch is mated by this white gear to our planet carrier. So the clutch, I guess, is really acting as maybe like a suspension, but it's going to resist any torsion of the planet carrier. So the planets are going to spin. When the planets spin, they engage our drive cone, right? So they're going to go. So when I spin this output, right? Call it the output shaft. When I spin the output shaft, you can see, oh, look at that. The planet carrier is spinning. That's strange. Why would it do that? I thought the planet carrier is supposed to be fixed. Well, it is. Typically, this planet carrier is going to be fixed because really you've got some flexibility of that clutch, but not a whole lot. I mean, it's going to rotate just a small amount. The reason that we don't have any flexibility in this right now is that because of the very high gear ratio on that worm gear, we can't backdrive the motor. And that's why they tell you, do not turn the paddle counterclockwise, because you're either going to over torque the clutch, or you're going to try to backdrive that worm gear. The worm gear is plastic. You're going to strip it. So that's what's going on. If we turn this on, see? Clever, right? Okay, so that's going to sit in there just like this, right? And as the motor is trying to turn everything, it's going to interact with this clutch. Sorry, it's going to interact with the clutch. And that's going to wind up a torsion spring in there. So this is covered under a little housing. Okay, so there's our intermediate gear, and this guy comes out a little gingerly. It's kind of tight. It's got a tight fit because we've got all the force from that torsion string, which is going to try and twist things around on us. So it's really tight on its bearing surfaces. They did a really nice job on the engineering here. So there it is. There's our torsion spring in there. This nub is going to be what kind of acts against. You can see there's a ball detent in there. That's actually a detent. So that's a spring-loaded detent It's black. And then another heat insert brass shaft, and then a really big ring bearing here. Like this hopper has got more bearings than any other hopper I've ever seen, and bigger and higher quality bearings too. Very expensive bearings. This guy's got, so this thing has got needle bearings here. You can kind of see in there, maybe kind of hard to see, but it's got roller bearings in there. Then it's also got a ball bearing on the end, and that's because this rotates within here. It's got to be able to rotate, you see, and that's got to mate up to our torsion spring. Alright, let's see. I need another hand to put this back together. See, I don't have like streamers bench or nothing. Yeah. There's my gaming fucking streamer webcam. It looks like I stole it from like a fucking 2008 fucking high school multimedia center or something. So that's not gonna work. Alright. So let's see. I don't know if I'll be able to get on this detent in a way that you'll be able to see it, because it uses a really strong spring. I really don't even know why they use a ball detent here. So you can see, all right, I do get a little bit of flexion out of it. I don't know why they use a ball detent here. I really don't. Maybe to save that worm gear, but it's crazy because the expense of all, there's another, now they've got a threaded heat set insert. I've never taken this off, so let's do that. Let's take this piece off. But like, this is quite an expense to save a worm gear. I don't know. Okay, so this thing is all the way in, and then you back it off half a turn or 3/4 of a turn. Alright, gotta remember that as I'm taking this thing out of here. This is M3.5. Okay. So there's that part right there. Got a spring. Gonna lose it. Okay, and there's our D10. Here. Alright. Now I'm just gonna put this thing back together and just kind of show you how it runs. Alright, and final thing to note here, I guess. This the battery pack, there's nothing holding the battery in except for just the geometry of the tray. It's gonna actually kind of like hold it in there passively. Come on. Putting it back together with one hand is like not super easy, but with two hands it is actually pretty easy. Whoops. Alright, I got it back together. Anyway, so you can see, yeah, see, so that, I mean, that battery is free to wiggle around a little bit, but they really got it like actually really pretty snug in there. It's like they spent a lot of time on the tolerancing. And this thing has so many plastic pieces. It's like, here's a plastic piece, 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 here's a plastic piece. There's another plastic piece underneath there that we didn't even get to yet. And then the electronics housing is like, well, phone died while I was ranting about the plastic pieces. Alright. So I guess I'll just show you kind of, because you might be curious. What about this thing here? Oh, hold on. Wow. And so this is like a harder plastic, and then it's got overmolded like a softer thermoplastic, and that's got a screw here and a screw here. So this black piece is actually removable itself. There's so many pieces here. And what I guess while we're here, let's take this apart. I haven't done that yet, so let's do that. All right, so here's our full electronics package, all taken out of here. This kind of mounts in there. It's actually like is that 8 pins? There's an 8-pin TFT, which is I don't know, some sort of full color transistor screen, supposedly better than an LED or something right now, but it takes a lot of like crazy magic to make it work. Here's the main board, and then this board, I think that this has got the driver on it and some sensors, the motor driver on it and some sensors. Here's that sensor that I was talking about. It's AS5600, which I look up here, and that's actually, it is a Hall effect sensor, but it's a magnetic encoder. So it measures the rotating magnetic field vector in the horizontal plane as the magnet spins. And it says that the magnet needs to be diametrically magnetized, meaning north and south are on opposite sides around the diameter, not top and bottom. I'm used to seeing these cylindrical puck type magnets being like the top is north and the bottom south, but if I bring them together, we can see pretty quick that that's not the case. Over here, it doesn't want to go on this side, but over here it clicks right down. See, so that tells me that this magnet there is diametrically magnetized. All right, so we learned something cool there. All right, and then so what's this chip right here? Let's see if we can see what this bad guy is. Hard to do this single-handedly. Oh, they've got everything. They've got a lacquer on everything, and that's kind of making it hard to see. But I could see enough to see that it was upside down. What does this say? Can't read it. I can't read it. Oh. Golly. Can't read it at all. I'm going to have to use 2 hands to read it. Here's the main chip. What we got here? STM32G DB1K ET6. STM32G. Let's see here. STM32G DB1K ET6. I'm pretty sure that this is a pretty quick, 32-bit ARM Cortex M0 Plus. It's got the B1 feature set, biggest of the G0 line. Nice. 512 kilobytes of flash. Nice. So this is a pretty fast chip. It's running at 64 megahertz potentially. It's got 3 I2C buses, 144K of RAM. USB 2.0. Okay. Multiple I2C peripherals to talk to your AS5600. DMA support so you can read encoder data without hammering the CPU. I don't know what DMA is. Digital multiplexing or something. to try to get data off the AS5600 faster. Because analog to digital is like CPU intensive, I think. Enough flash for a real application. So they've got a lot of flash and they've got a lot of RAM. So they must be doing some actual math as well, trying to figure out how much. Probably they're doing some. Okay, so the phone died again, but in the meantime, I did some nerd down on this. This bad girl's got an STM32G running at 64 megahertz. That's pretty quick. That's a pretty powerful little processor right there. And over here they've got, what did I write down? Is it a megabyte? Megabyte of flash? Yeah, I think so. Yeah, so we've got a megabyte of flash memory over here. This is probably storing like user settings, stuff like that. This guy, bet you that this is a slave, because there's actually another STM32G over here. There's another STM32. This is probably the master. So this guy probably just handles user interface, buttons, GUI, the UI, and then this guy does all the crazy math that's trying to control this motor. So it's probably handling that sensor that we talked about before. Don't know what this is. This, I don't know. Over here, I think we've got like that's a pretty chunky inductor. This is probably our power supply over here. Here's a whole bunch of transistors. So this is probably our motor driver section, and this is probably being run by our brain over here. And this is handled. Yeah, that makes some sense because it's in proximity to our sensors. Got a sensor over here. This is our charger. So I don't see like a charge controller. Maybe this is our charge controller, but you would expect it maybe to be over here. So maybe this is taking care of charge control too, because it is a lithium-ion battery, so it needs charge control. This is a thin film transistor, a type of liquid crystal display that uses thin film transistor technology to control individual pixels. This technology allows for better image quality, faster response times, and improved color accuracy compared to older display types. Great. So there you have it. I think we probably nerded out enough on this. Probably learned more than you'd ever need to know. One millifarad, 1,000 microfarad. Yeah, that's the whole ball game right there. So the reason I think that oh Jesus Christ, I haven't even turned it on for you yet. All right, I guess I got to show you how it works. You know, and frankly, it really is just like super easy to put this thing back together too. I just had it totally tore down, put it back together. I don't even have any extra screws here. All right, so we've nerded out for like 45 minutes going over this thing, more like an hour. Here's what's really interesting, right? So I put my finger in there and that stops it, but how am I going to show you this with only one hand? If we oh shit, I need something that goes up into the feed neck. If we tickle it in the feed neck, so if we tickle those eyes that are glowing red, that actually, golly, come on. So if I stick my fingers in there, you see it? So when I break the beam, it's when I break the beam that it actually jiggles a little bit. Okay, and it only does that when I've got it at full lock, right? When there's already load on the stack, that's the only time that it's going to jiggle forward. So and it only really tries to twist it further. So it doesn't even seem like they're being used for anti-jam. They're they're like a signal like, hey, a paintball has dropped. It's time to actually juice the motor just a little bit more, as if this tension on the stack wasn't enough. Give it another little shot, right? Is what it seems like to me. Right? Because right now we've got it jammed. There's no paintballs in there. It's jammed, right? We know it's jammed because there's no paintballs in the feed neck. So it must be jammed. It should be spinning backwards right now, but it's not. So those eyes are there just to tell it, hey, bump forward because you've got to catch up. I really don't understand it, actually. And there's plenty of tension on this right now to be able to feed paintballs much further than just 2 inches into the breech of the chamber. They do have some really nice anti-jam technology in here. This is like a step forward from even what Empire is doing. They've got kind of like a flexible little plastic piece, but here they've taken it a step further with a little like neoprene shark wing. And then, like I said before, with this ramp, kind of similar. I think the Spire does have like a lip over top of the Raceway, so that balls that are going around on the outside are not being like less likely that a paintball is going to kind of jam itself in there anyway. So it's going to get ridden out. I think that's a really nice feature. So paintballs kind of start in the middle and spread out. Overall, very clever. Lots of engineering went into this. Lots of thought, lots of effort. There are some things that I think are like, I don't know, extra. This detent, I don't know, like this. Is it the same that Save That Worm gear? I guess so. They've got 2 USB ports, so they've got a USB port here, USB-C, and it's just for charging. And this one, apparently, the USB Mini, like, I haven't used this connector since I got my first Android when I was still in high school. But I guess that's how you update the flash. I really don't know. They do have the JTAG and test pins available. I don't know if I really want to go down the rabbit hole of trying to reverse engineering their software. Who knows if that port is even open. It would be cool if it was, but so there we go. So I'm gonna work on 3D scanning this, and I guess that would be the next thing. All right, a couple last things here. This guy's about 9 inches long, and it's about 4 inches wide. Just take my word for it, but a like 77 or 80 cubic inch tank is 4 inches in diameter and 9 inches from back to front. That's back to front of the pressure vessel, not the regulator and the call it like the neck coming out of the bottle. So very similar size, right, to a bottle. There are a couple of little features here. There's this little nubbin and this little kind of columnar thing. I just sprayed it with this 3D scanning spray. There's a Revo Point Inspire 2. It has an accuracy of, I believe, 0.3 millimeters, but I think a lot of that's marketing, but it does seem to work. But it is limited because it's like a $500 scanner. So those little notches gotta hook up to these guys, right? There's like little columns in there as well. Yeah, very highly sculpted interior here. What else is there to say about this? Not too much, really. I'll just throw it back in there for one final look, and then it's going to be tough because we're working remotely, but Oh, we'll work on it. So, yeah, we'll work on it. Come on. There we go. So there it is. Shut up, Joe. Oh, here's that TFT display, but you're not going to be able to see that. Oh, it's coming through. So there you can see. Yeah, I mean, it's full color. It's got a bunch of different buttons and bullshit. It's pretty cool. And it looks even better in person. I can see it much better than even you can now. So it's neat. It's really neat. I don't know what all these buttons do. I don't really care. And that is usually the limiting factor on frame rates and resolutions that you're